Right, let us continue preparation methods. In the last class we completed Gutterman. Right. Yes, now done. Reimer-Tiemann reaction. Reimer-Tiemann reactions. Conversions are very important. I given conversions in the last class also for every reaction. Reason conversions kuda chuskondi. Right. Continuation of preparation of carbonyl compounds. Next, Reimer-Tiemann reaction. Reimer-Tiemann reaction. You know this reaction very well. Phenols when treated with chloroform CHCl3 in the presence of KOH or NaOH gives ortho-hydroxy benzaldehyde, commonly called as salicylaldehyde. Ortho-hydroxy benzaldehyde, commonly called as salicylaldehyde. This is another preparation method. Okay. Surabhi, నిన్నటి క్లాస్ అంతా ఫాలో అయ్యావా సురభి? నువ్వు సురభి నోట్స్ రాసుకున్నావా? నేను గ్రూప్లో పెట్టాను, నోట్స్ చదువుతున్నావా? అది ఒకసారి ఫాలోఅప్ చేస్తాను నేను. ఓకే, వైష్ణవి కార్బోనైల్ చాప్టర్ మనం డిస్కస్ చేస్తున్నాం. ఒకసారి నువ్వు ఆఫ్లైన్కి రాను, మనం డిస్కస్ చేద్దాం. Right, okay. Next, let us prepare aromatic ketones. Aromatic ketone. How to prepare aromatic ketone? See, when benzene treated with acetyl chloride, this is called acetylation. Acetyl chloride will get a acetophenone. Acetophenone is formed. How to write the mechanism? Shortcut mechanism. See, let us consider hydrogen here. Okay, see the mechanism. How to write the product? Remove this. Remove H and Cl. See, remove these two. And attach C double bond at this. Okay, so what you will get? A acetophenone is formed. Okay, right. This is for aromatic ketones. Benzene when treated with acetyl chloride in the presence of AlCl3, remove hydrogen and Cl, and attach the C double bond to the benzene. Very simple. Remaining part. Attach remaining part. Right. And some other preparation methods. First I given very important named reactions, but not in the order according to important priority. Okay, continue. So many other reactions also there. Next, keep heading from preparation from alcohols. This is well known reaction in alcohols. Oxidation, everyone knows about. Actually, they no need to explain this clear, because in alcohols we did. So just let us revise the reactants or reagents. We completed preparation of carbonyl compounds already indirectly. In alcohols chapter, we did the chemical properties of alcohols. Right, chemical properties of alcohol, nothing but preparation of carbonyl compounds only. Look at this. Which reagents we use? Tell me. Which reagents we use? Mild, yes, mild oxidizing agents. See, PCC, PDC, pyridinium chlorochromate, pyridinium dichromate, copper 300 degrees centigrade, silver 300 degrees centigrade, CrO3, acetone, in anhydrous conditions. Anhydrous conditions. Even halogen also considered as a mild oxidizing agent like chlorine, bromine, halogens. So when we use mild oxidizing agent, what we will get? We'll get aldehyde or ketone. In alcohols we did. Let us take one example. CH3 CH2OH. Sanjana only didn't listen, right? I'll send the mechanism, simple mechanism. You can watch the video. See this. When we use PCC, pyridinium chlorochromate, or Jones reagent, CrO3, CH3CH, aldehyde is produced. Primary alcohol gives aldehyde. If I take secondary alcohol gives ketone. Any mild oxidizing. What are the mild oxidizing agents are there? All that mild, copper 300 degrees centigrade. Here you will get a ketone. The mechanism, everything was explained already. Okay, everything was explained. We will discuss. And you know what is MnO2? What is the role of MnO2? Online students, can you say what is the role of MnO2? Allylic and benzoylic. MnO2. See, MnO2. Special reagent. This is also covered in alcohols. MnO2, manganese dioxide. For allylic oxidation, OH group present in the allylic position is oxidized by MnO2. See, allylic alcohol and non-allylic alcohol. Once look at this. Here we have two alcohols. What is allylic position? The sp3 position, which is next to sp2. sp2, this is sp3. This is allylic position. This is allylic. In allylic position, alcohol is there. So this is allylic alcohol. This is non-allylic alcohol. So MnO2 oxidizes only allylic. MnO2 oxidizes only allylic. Non-allylic alcohol won't be oxidized. Non-allylic alcohol will not be oxidized. But when we use the CrO3 Jones reagent, what happens when we use CrO3 or copper 300 degrees centigrade? CrO3, both will be oxidized. So that is the importance of MnO2. MnO2 particularly oxidizes allylic OH only here with MnO2. With CrO3 all. Okay. Right, next preparation from esters, preparation of carbonyls from esters. How to prepare? Any idea how to prepare from esters? See, ester when treated with a dibal H, diisobutyl aluminium hydrate, dibal H. Very simple preparation method this is. See, Sanjana, break this bond. Carbonyl carbon oxygen bond. Single bond. Add hydrogen and hydrogen. Very simple. Clear? R C double bond O H plus R OH. Aldehyde is produced. Very simple. Break carbon oxygen single bond. Most important preparation method. Very important preparation method. Okay. Let us see one example. CH3 C double bond O, 2 CH3, diball H, diball H. How to write the product here? How to write the product? Hydrogen here and H. CH3 C double bond OH and CH3 OH. Aldehyde and alcohol. Important preparation method. CH3 OH. Okay. Calling everybody. Hello. Right. Diball H, diisobutyl aluminum hydrate, diball H, and lithium aluminum hydrate. Actually, this is not our reaction, right? But already we did this, right? That's why I'm giving. For new students, it may be difficult to understand, but just write. This is our original reaction, preparation. You know how to write the product when ester and diball H both are added. How to write the product? Break carbon oxygen single bond. Break this bond. Just now we did, right? H here and H here. Okay, right. Over. Diball H do not oxidize carbonyl group. It will present as it is in the product size. So you will get a aldehyde group and byproduct is alcohol. See, in the same functional group, aldehyde is forming and ketone is forming, right? With lithium aluminum hydride,
is only ketone.
It is a powerful reducing agent, versatile reducing agent, reduces all types of functional groups. Ester also reduced, okay? And the mechanism is given already for you in the alcohols. So what you will get? You will get a OH here and here you will get a CH2OH. This bond will break and CH3OH. Okay, once watch preparation of alcohols or see. You wrote already in your books, clear? Look at this, but this is not our reaction. Just I revised the role of lithium aluminum hydride, clear? Just you focus on this only. If you interested, just revise once alcohols preparation, clear? But this week this is not there. But under properties we can write under properties. Under properties. We can discuss under chemical property now. Nucleophilic only there, but in the chapter this will come under reduction last at the end, but this week not there. Only nucleophilic reactions are there, so focus on this. This is already given previously, not new reaction, this reaction. Sanjana. Online students, clear? Look at this only, this part only, okay? No doubt, online students. Please respond, all of you. Online students. Surabhi. The preparation from esters is over. Next, keep reading. Preparation from carboxylic acids. Preparations from carboxylic acids. Preparations from carboxylic acids. Carboxylic acids to carbonyls. How it is possible? First of all, calcium salt of carboxylic acids. Calcium salt of carboxylic acids. when heated are subjected to distillation. When heated are subjected to distillation. When heated are subjected to distillation. I am not writing complete word. Subjected to distillation. When heated are subjected to distillation gives ketones from carboxylic acids. Okay, look at this. RCOO. You tell me. Carboxylate ion. This is carboxylate ion. Correct only, na? How many negative charges are there? 2 plus 2. So can one Ca plus 2 compensate 2 negative charges? Yes. So I am writing this complete structure like this. RCOO taken twice Ca. Just now I given, na? For 2 units, 1 calcium is necessary. So when it is subjected to heating or distillation, ketone is formed and CaCO3. CaCO3 is the byproduct. See the mechanism. RC double bond O. Look at this. O negative, negative in the between Ca. This can be written like this. RCO 2 times and 1 Ca. Very simple shortcut mechanism. Very simple, very easy. See, look at this. Ca, C. How many oxygens are there? 3 minus CaCO3. Remove this. What is the remaining part? Okay, note down. Shortcut mechanism. Right, let us see one example. CH3COO. Actually, wait for some time. Sometimes you won't get direct calcium salt of carboxylic acids. That is the twist. Sometimes you will get like this. That is the objective exam. Okay, specialty. They won't give calcium salt directly. First they will give a reaction like this. Okay, then calcium salt of carboxylic acid is formed. Clear? Now heating. CH3, C double bond O, CH3. Acetone is formed. Okay. What is the mechanism? CH3 C double bond O, O. CH3, C double bond O. How many times? 2 times. 2 times. So I wrote 2 times. CH3CO taken twice, na? So I wrote 2 times. And how many calciums are there? So what we have to remove? CaCO3. Remove this. And attach methyl group to carbon to form acetone. Okay, same shortcut mechanism. Next, keep reading. Preparation from alkynes. This is also important method. This reaction came 2 times in the tell me NEET exam. Preparation from alkynes. From alkynes. Preparation from alkynes. This is alkyne. Tell me. HgSO4, mercury sulfate, H2SO4. This reagent also represented like this. Okay, sometimes it is represented like this. Hg plus 2 followed by H plus. Both are same representations. Same. And B2H6 THF followed by oxidation H2O2. Here you will get ketone. Ketone is formed for this. Here you will get a aldehyde. This reagent adds water molecule to alkyne according to Markovnikov's rule. This reagent adds water molecule to alkyne according to anti-Markovnikov's rule. Let us see the mechanism clearly. Write the rules first. Write the rules. This entire reactant adds water molecule to alkyne according to anti-Markovnikov's rule. Adds H2O according to anti-Markovnikov's rule. Anti-Markovnikov's rule. This entire reagent adds water molecule according to Markovnikov's rule. Adds water according to M rule. According to Markovnikov's rule. CH3 HgSO4 H2SO4. First I'll write the product. CH3 C double bond O CH3 acetone. Look at this mechanism. What is the role of this reagent? This total reagent adds water molecule according to Markovnikov's rule, according to M rule. Water, what is the negative part of water? OH minus and H plus. See, listen first. Important part. You are adding 2 atoms. Then triple bond will convert it to double bond. CH3 C OH. Can I write OH like this? HO or OH? O bond H. All are same only na? CH2. Here H is there, only H is attached. Markovnikov's rule means negative part of the reagent adds to carbon with less number of hydrogens. Okay? If there is no hydrogen, less number. Clear? Now, one phenomena will take place. You have to remember that is based on the isomerism. Tautomerism. The phenomenon is tautomerism. I am writing this bond some bit lengthy. See here. This is tautomerism. Shift this bond in between these two. Which bond? Which bond? This OH bond, like this. Okay. Then this carbon will get how many bonds? 5. 5 bonds are not possible. 1, 2, 3, 4, and one new bond is coming. 5. But 5 bonds are not possible. So whenever you shift the bond this side, this pi bond will shift towards carbon as a negative charge. As a negative charge. Clear? This will get negative charge now. We know if any atom will gain the bond, it will get a negative. It will get negative. And what about this hydrogen? This hydrogen is losing the bond or not? Hydrogen is losing the bond or not? Okay. So this hydrogen will shift towards that carbon, which is going to get a negative charge. See, once again, see, look at this. Hydrogen is losing its bond. That's why hydrogen will come out as H+, as a H+, because it is giving its electron to carbon. This electron belongs to hydrogen, that is going towards carbon. Hydrogen is losing its electron, so it will release as H+. So now in between these two, double bond is there. But around carbon, 5 bonds are not possible. When you shift like this, 1, 2, 3, 4, 5. 5 bonds are not possible. So when you shift like this bond will shift towards carbon and accumulated as a negative charge. Look at this. As a negative. That negative and this H+. Neutralization. Okay? Right. This is tautomerism. CH3. C double bond O. CH3 ketone is formed or not? Yes. Very important reaction. Do you have college tomorrow, Srijan? Holiday? Right. Next. With BH3 THFR B2H6 H2O2 OH negative. Sometimes BH3 can be represented like this, B2H6 also. Role of the reagent is same. Means when you take B2H6 or BH3, role is same. What is the role? Adds water molecule according to which role? Anti-Markovnikov's role. Anti-Markovnikov's role, negative part. This reagent releases water. Okay, H2O. What is the negative part in water? OH minus. Negative part adds to carbon with a more number. Positive part adds to carbon with a less number. Like that. Clear? So I am giving the mechanism here onwards only. Look at this. Wait for some time. After adding, what happens? CH3. Here hydrogen is forming, right? Hydrogen is attaching. CH. Can I write this bond like this? OH. Any doubt? HOH. Next. Look at this. shift this bond in between these two. Here new bond formation take place, but around carbon 4 bonds only present, 4 bonds only, 1 2 hydrogen 3, this bond 4, and new bond is coming 5, not possible. So immediately this pi bond will shift towards this, and this carbon will get which charge? This will get which charge? If one atom gets bond, then it will get which charge? Negative charge. And hydrogen go towards that. Once again see, shift this bond, attach hydrogen. So CH3, CH2, C double bond OH, that is nothing but aldehyde. Aldehyde properties, chemical properties. Chemical properties. Carbonyl compounds generally undergo nucleophilic addition reactions. The characteristic property of carbonyl compounds is nucleophilic addition. Nucleophilic addition. Look at this. You know, carbon oxygen, nature of carbon oxygen bond is highly polar. I given in the class. Highly polar. Polar means presence of negative and positive. Negative and positive. This positive charge adds to nucleophile. I mentioned this point also. Nucleophile. Nucleophile is negatively charged. Nucleophile is negatively charged. So nucleophilic addition reaction takes place. The characteristic property of carbonyl compounds is nucleophilic addition reactions. Clear? Like this. In nucleophile addition takes place because carbonyl carbon is having positive charge. Carbonyl carbon is having positive. Okay. So nucleophile adds to that carbonyl carbon. And what about this oxygen? Whenever we attach nucleophile, it will get 5 bonds. Now that's why this bond will shift to this side. That's why I wrote negative charge. Clear? Because 5 bonds are not possible. Now, when you attach nucleophile, what happens? It will get 5 bonds, but 5 bonds are not possible. Right? So the characteristic property of carbonyl compounds is nucleophilic addition reaction. Nucleophilic addition reaction. Comparison of reactivity. The reactivity comparison is very, very important. Okay, let us say, you know, inductive effect. Everyone knows about inductive effect. Inductive, that is useful now. This is very important, and for that we need inductive effect knowledge, and everyone knows about inductive effect, electron displacement effect, right? Let us compare aldehydes and ketones, which are more reactive towards nucleophilic addition. Very simple concept. I am taking aldehyde here, aldehyde, and I am taking ketone. Can you guess anybody which is more reactive towards nucleophile? Here nucleophile is waiting. Nucleophile is waiting to attack. Okay, nucleophile is waiting to attack. This is carbonyl carbon. This is also carbonyl carbon. Right. First one is aldehyde. Second one is ketone. This nucleophile attacks fastly or readily which carbonyl carbon? Aldehyde carbonyl carbon or ketone carbonyl carbon? And why? That is a question to you. What is the key point I wrote here? Once you go back to this carbonyl carbon is having positive. Why it is having positive? because of electronegativity difference. Oxygen is more electronegative. Clear? So this nucleophile attaches to positively charged carbon. Positively charged carbon. Clear? That is the key point. For nucleophilic addition, more positive charge should be present on the carbonyl carbon. That is the key point. For the nucleophilic addition, more positive charge should be present on the carbonyl carbon. Clear? Look at this. What I am writing, observe this and tell me. Large positive charge, small positive charge. Why? Why I wrote large positive charge and why I wrote small positive charge? Why this carbonyl carbon is having large, bigger positive? Why this carbonyl carbon is having smaller positive? Okay, I will explain the reason. Keep aside. This nucleophile preferentially attacks this only. Why? Here positive charge is more, so negative charge goes easily and attacks. Here positive charge is less, so here nucleophile goes slowly and rate also less. Rate also less or slow. Clear? Why it is having large positive means to this carbonyl carbon left hand side only one plus I group is present, and plus I groups donate electrons. Plus I groups donate electrons, right? Plus I groups donate electrons and they nullify the positive charge. They nullify the positive charge. Okay. In ketone, this side one plus I group is there. This side one plus I group is there. Two sides plus I groups are there. Two sides plus I groups are donating electrons. Right. So the bigger positives will become smaller positive because they are supplying electrons. Electrons are coming here, positive charge is there. So electron positive means negative positive means neutralization. Negative charge is coming, electron coming means negative charge is coming. Here positive, negative positive neutralization. So less positive. So generally which are more reactive in between aldehyde and ketones? Aldehydes. Because in aldehyde carbon, carbonyl carbon of aldehyde contains large positive charge. Carbonyl carbon of ketone contains less positive charge. So if we write the reactivity comparison, if I write like this, Nu1 nucleophilic addition rate 1, Nu nucleophilic addition rate 2. So what is the relation? RT is greater than R2 or R1? Sorry, R1 greater than R1 greater than R2. Okay, just a Alright, good evening everyone. Hello. Am I audible to you? Hello, Meenakshi, Radhiva, Aisha, Bhakti, Sujan, Kritika. See, we are almost completed. Yes. Well, additional information I will give you. If possible, remember otherwise complete. Okay? So additional data. After completion of few properties. What is the last reaction? Reaction to sodium phenoxide is there. Okay? Right. Now reduction of phenol. Coupling reaction is over now for second batch was yesterday. Adiva, Meenakshi. That is coupling reaction also completed. Coupling reaction. Reduction of phenols. Reduction of phenols. Reduction of phenols. See, I am taking phenol in a test tube. This is phenol, and I am taking alcohol in another test tube. Alcohol in another test tube. I am adding neutral ferric chloride. Neutral FeCl. Neutral FeCl. Neutral ferric chloride. Here also I am adding neutral ferric chloride. Neutral FeCl. Okay. If you observe violet color, formation of violet color indicates presence of phenol in the test tube. Violet coloration. Violet color formation. What about alcohols? Alcohols in which color or they do not give any color? Alcohols. The alcohols react with neutral ferric chloride. No color is found. So, FeCl3 is used to distinguish alcohol and phenols. Which of the following reagent is used to distinguish alcohol and phenol? What is the reagent? Neutral ferric chloride. Distinguishing. See, neutral ferric chloride reacts with phenol only, but it does not react with the alcohol. So, you can use this reagent to distinguish. Distinguishing. Let us see the reaction. Okay. Shall I clear this? Online students. Shall I clear this? All of you. Phenol formula C6H5O. Phenol is FeCl2. C6H5O enterprise yes, HCl. This is the balance equation. Iron trioxide or iron phenoxide. Simple name iron phenoxide. What is the color? Violet. Which of the following reagent is used to distinguish alcohols and phenols? Neutral ferric chloride. Neutral FeCl. Okay. Uses of phenols. What are the uses of phenols? I think uses for college. Uses of phenol. 42% phenol is used. Is used as disease protection. And phenol is used in the preparation of dyes. Yes, yesterday we prepared dyes, rice. It is used in making dyes. Colors. It is used in making medicines also, like aspirin. Manufacturing drugs. Medicines. Yes. Hello? 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 Yes, tell me. I'm not audible to you. Okay, but I'm audible to you. Are you getting what I'm explaining? Okay. Just a second. Finish. I'm audible now. Meenakshi, once tell me. Hello. Hello? Hello? Right. Right. This is about organic chemistry and the phenols also completed their nutrients design. Phenols, Lucas, hydrate plus, Myra and just D block chemistry. You have D block chemistry complete short about D block was finished before that. I'll give you one shot about D block chemistry. What important points. Completed finance complete properties also. Okay. Let's tell you. Bromine water reaction also completed na? Bromine water reaction. We can use water. We can use the distribution also. Bromine water do not react with the alcohol. We can use that also. Because basically is not present alcohol, around bromine attacks alcohol. We can use that also. Bromine water test. What is that? Shorter government. Shorter government. Degradation of phenol. In presence of these, this is benzoic chloride. Yes, what will be eliminated? What will be eliminated? HCl. HCl will be eliminated. Now this part is going to oxygen. Right? Gases, oxygen atom molecules. Okay? And this is our oxygen. This is our phenyl benzoate. You can call it phenyl benzoate. That's right. This is short-term bond. Dehydrogenation in the presence of these is called short-term bond reaction. The completed acetylation, the reaction, oil of reaction from acetyl salicylic acid, acetylation. Aspirin preparation is about acetylation. Subtopics. Ether preparation properties and no subtopics in the ether preparation and properties. You can watch them. Water preparations. Williams and synthesis preparation from concentrated sulfuric acid. Major preparation process. After that, cleavage of index. Chemical properties. SN1 is something that can be explained. Carnitine is something that can be explained. This is additional reaction, short-term bond reaction. You can Right, another reaction also 5 cell actually small count of the but right and the forward 5 cell main mechanism. Well, once and acetyl, what is the production? CH silver bond of CO2. What is the production? This reaction, where we did this reaction in aspirin. What is the mechanism here? Same, HNCl will be eliminated. You know this reaction? This reaction is over already in the aspirin preparation. Sir, no? You know which group or black acetic or can you use acetic anhydride also? Again, already this this phenol aromatic ester. Phenol this phenol any idea what price migration? While it is treated with PLCL3, rearrangement takes place. The rearrangement takes place. And a little shortcut method. Once you can stop writing. Here on hydrogen is there. Hydrogen is present on. Actually, if you write mechanical, the number of steps you use, you can write direct program. No problem. Here hydrogen is present. Here also hydrogen is present. See this C double bond here. This is attached here. Okay. Here hydrogen is present. Attach the hydrogen to the oxygen. Here already hydrogen is present. Right? C double bond duo CH is coming to this place. Then hydrogen to the place. Right? And similarly in the para also, hydrogen is there. Attached to the para position. And here hydrogen is there. Attached to oxygen. This is called 5-cell ring. Actually this is 5-cell ring. Again one additional reaction. These are optional or this short and long and 5-cell arrangement. Okay. Maybe these are not elements. But the legal term, we will do that. If you do not get anything about this, you just skip it. Okay. Molecules, we will do orthohydroxy phenyl methyl ketone. So this is orthohydroxy phenyl. This is phenyl. This is methyl. In ortho position, hydroxy group is there. No? This is orthohydroxy phenyl methyl ketone. Orthohydroxy phenyl methyl ketone. Orthohydroxy phenyl another one is para-hydroxy or para-hydroxy which is major for region value. What is the region character? over -5. Would you write interstones? Anybody? Interstones. That's posterior. Okay, goes to the structure. Then actually yesterday I gave you that reaction, but direct conceptual type there is no mechanism in that. You have to follow like this. See, have you talked about that previously or last week? Look at this. When you feel then you will concentrate the circuit, concentrate the space. Let's go three much deeper. Sulfuric acid increase integrated in the or the application. Okay. If you want, what is this name? Second member for production sulfuric acid increase there. If you want 2,4 disulfuric acid, then you want 2,4 disulfuric acid. I already given this in last week. Disulfuric acid. This is when we get the concentrated reduction of the convert to the approximately conditions in places. Okay, this is conceptual type only. Active. NaHCl. Phenol contained with the NaHCl. This is integrated with the NaHCl. See, carboxylic acid. When we add elements, here reaction is strong acids react with NaCO2. This is a base, there should be a base. Only strong acids, there are other acids. Actually, phenol comes under weak category. Phenol comes under weak acid. But when three NO2 groups are attached to the phenol, this nature increases, which also acts as a strong acid that will react with NaHCO2 and with CO2 gas, carbon dioxide is the product. In this case, RCOO plus CO2, otherwise CO2, this carbon is here. Here also RCOO, CO2, also strong acids will liberate strong acids will liberate CO2 gas. You know, not liberate CO2 gas. Maintain sulfuric acid also will be considered as a strong acid. It also uses CO2. Okay. Got it? Actually, the GOC during comparison of overall picture, you will only strong acids and exceptionally, because of the people and reduce CO2, which is the highest hydrogen reduction double bond OH reduction model which will hatch power only benzene will be reduction. Only use hatchay which will reduction. Alcohol reduction reduction. Okay, now let's do allow the these ingredients. Material questions will be coming. And discuss. And the in the very down in the feedback elements, we will tell you that. We will use the machine organic mechanical. Main intention is to complete feedback elements. Because the orientation, what topics we will in the feedback elements. So let me some questions to you. Have you prepared all of the feedback elements? Feedback elements. No. We completed feedback elements only students. Already we finished feedback elements. Feedback elements. Not last week, before that. Actually, feedback element master this week. That is already completed. Right? So we finished before that, before IT exams, not after IT exams. Already we lectures are there. Already English is over for you in the regular. Yesterday given as a regular shopper. Otherwise they will be from the building hands. Okay. And how regular just starts. This time saving part. First of all, do that. You will feedback the books. Anyone? Feedback. Susan, have you completed feedback elements? You are ready. Adhika, you? Ayesha, sorry. No idea. So you Adhika? And I have to what I am asking, do you read feedback elements? You know feedback elements? Reduction potential? How to do? Remaining are completed. ATM, potassium permanganate, potassium bicarbonate. That's it. Only up to okay, oxidations everything. Which is good oxidation in this one? Oxidizing agent. See that is. Which is correct relation of the science. Because if I don't go to knowledge levels in feedback, Pantala is equal to UV. Okay, for the order which is stable oxidation is equal. What is the reason? What is the reason? Molecular electron configuration, palladium electron configuration. Right. Okay, I will give you one brief about these categories. Right. Is definition of homogeneous dimensions differential equilibrium into analytical integration. You are of analytical integration. You are of these are elements present in the equation of the periodic table. Equation of the periodic table. Just a little random this is clock, this is speed clock, that clock is this, that clock is this. And so just focus on the portion. Give a group number. Longitude 3, 4, 5, 6, 7, 8, 10, 11, and 12. Okay. Let's just start.